guys, this is another integral from the University of Nairobi sample equation. As you can see, we are told to integrate that. So it will be lengthy, but it's worth it. So as you can see, this will just use trigonometric substitution as we said. So from here, I'll factor out my 4, okay? But before that, as you can see, this is where I will replace my x to be a tan of theta. I just maybe a preview. We have 3 formulas in trigonometric substitution, 1, 2, 3. Just write them easily or quickly. When I'm given the integral of the square root of a squared plus x squared dx, I'm told to choose my x to be a tangent of theta, right? As you can see, this is just the square root of a squared x squared. As you can see, I'll get that. When I'm told to find the integral of the square root of a squared minus x squared dx, I'm told to choose my x to be a sine of theta, right? When I'm told to find the integral of now x squared now minus a squared, okay, dx, I'm told to choose my x to be secant of theta, a secant of theta, a secant of theta, right? So as you can see from here, I just use my first expression. So I'll use my first expression, but now I'll have to factor my 4. Let me factor my 4 out, so I'll get the integral of the square root of my 4 into x squared, okay, plus 5, right, dx, okay. So this is just the same as the square root of 4 multiplied by the square root of that. So I'll get the integral of the square root of 4 multiplied by the square root of x squared plus 5 dx, right? What's the square root of 4? It's 2. So I'll just replace here. I'll write my 2 there. Okay, just write my 2 there. From our knowledge, any constant term outside the integral, take it. You get outside it, so it will be 2, the integral of the square root of x squared plus 5, right? dx. Okay? Okay, so as you can see from here, we said we'll replace our x to be a tan of theta. Keep that in mind. Okay? Keep that in mind. So from here, let me just clear all these. So from here, I'm told, so I will express this thing, I will express root of 5 in terms of power. Okay? So when I write root of 5, then I raise it to the second power. It's just the same as 5, right? Okay, so I'll replace my 5 with this part. Okay? So I'll replace my 5 with that. So I'll have 2, the integral of the rad of x squared, right? Okay? I'm trying to raise that to. Then my root of 5 I'll write as root of 5, then I square it. Okay, then don't forget the x, as you can see. So we have evaluated our integral to be that. So from there, we say we'll choose our x to be a tangent of theta, right? So from here, the formula, as you remember, the formula says a squared, the integral of a squared, the formula says the integral of the square root of a squared plus x squared, right? dx. So my x squared, this is my x squared, as you can see. So my a squared is all these things. So I'll write my a squared is the same as the square root of 5 squared, right? So my a alone will be just the square root of 5. Okay? So from there, just replace into the formula. So I'll get my 2 integral of the square root of, okay? So what's my a? My a is square root of 5. So I'll get my x is the same as square root of 5 tangent of theta, right? So from there again, I'll find my x squared. From these, I'll find my x squared. X squared in these, I'll just square root of 5, I'll get my 5. When I square tangent, I'll get my tangent squared theta, right? Again, from here, we'll find our dx. So our dx, I'll be differentiating x with respect to theta, so I'll just write the square root of 5. What's the derivative of tan? It's just secant squared of theta, but now it's being reflected to d theta, right? So having that information, I'll be replacing that inside the integral. So what's my x squared? My x squared is that, so I'll write 5 tan squared of theta, okay, plus, what is root of 5 squared? It's just 5, okay, multiplied by my dx. I'll be multiplied by my dx, but what's my dx? That. So my dx will be the square root of 5 secant squared theta d theta, right? From there, I'll factor out my 5 inside there. I'll factor out my 5, so I'll get to the integral of the square root of my 5 outside into tangent squared of theta plus 1, okay, that way. Then I'll multiply that with my square root of 5 secant squared of theta d theta, okay. So we have that. So I'll just clear this. So the process is interesting, as you can see. So from here, I will get, what's my square root of this? Is just the same as square root of 5 multiplied by the square root of this. Using the Pythagorean identity for that, I usually say 1 plus tangent square root of theta is the same as secant square root of theta, right? So I'll replace all these expressions with that. So I'll replace that to that. So I'll get 2 inside the integral of the square root of 5, okay? The square root of 5, sorry, multiplied by now the square root of all these expressions, tan squared plus 1, and replace it with secant squared. So secant squared of theta, right? Then I'll multiply that with my square root of 5 secant square of theta d theta, okay? So I'll just take all my constant terms outside. So I'll be remaining with the rad of 5 multiplied by rad of 5 multiplied by 2, the integral of square root of secant squared is just secant theta multiplied by secant squared of theta d theta, right? The square root of 5 multiplied by square root of 5 is just 5 multiplied by 2, it will be 10. Okay? So I'll get, so the integral is long, but a bit, so I'll get my 10, the integral of secant theta multiplied by secant square of theta d theta. Okay? So from here, I'll try to explain something. As you can see, my answer, I'm supposed to write my answer as that, right? But now, I can decide to say secant theta multiplied by secant theta. I will get it as secant cubed of theta, right? So from here, you can use the reduction formula. I have a video on the reduction formula, so I can use the reduction formula for that, for secant to any power I can use my reduction formula if you have it directly in mind, but from this case, we won't use that. Okay, we just go the long method for that, but having the reduction formula for secant in mind, you can just replace your power of 3 and you'll get your answer. Okay, but for now, let's go the long process. Solve that. We don't have our formula at mind or in mind. So from here, as you can see, I won't multiply that. I'll just replace this part with the Pythagorean identity that says 1 plus tangent squared, okay, theta equals to secant squared theta. Okay, I'll replace that. Sorry. So, okay, another concept I will try to explain. So, once you reach here, you can use the reduction formula for secant to the cubed, but the long process now we'll have to use integration by parts. Okay, so we'll have to use integration by parts. We'll have to use integration by parts. In the video of trigonometric integrals, we said when you're given to integrate any power of secant, you can go the long method by integration by parts, or use the reduction formula for secant to any power to evaluate that. So for this case, we just use the integration by parts technique for that. So I want to be using the Pythagorean identity. Okay, I want to be using the Pythagorean identity. I'll instead use integration by parts. So from here, integration by parts, will be using the integration by parts. So we'll say the integration by parts formula, when you are told integrating u multiplied by dv equals to u multiplied by v minus the integral of v multiplied by du. We had seen how to do that. Okay, so I'll choose my u automatically to be secant. So my u will be secant. We had talked on videos on integration by parts. So my dv will be secant squared d theta, right? Don't forget 10. The 10 is outside, so let me just write it here for remembrance. And just write my 10 there. So from here, from the formula, we have our u, we have our dv, we have our u, don't have our v. So our v, we'll get it from here. So what will be our v? Our v is just now the integral of secant squared d theta. So our v is tan of theta. Okay? What will be our du? Our du is just secant of theta tangent of theta. Okay? So we'll replace that inside our formula. So remember our view is tan of theta. So our du is that, remember. So we'll get 10. We're told you are integrating secant theta multiplied by secant squared of theta d theta. Our answer is supposed to be u. What was our u? Our u was this, remember. Secant of theta multiplied by our v was tan of theta, remember. Okay, minus the integral of what was our v? Our v was tan of theta, remember. multiplied by our du. Remember, our du was tan of theta secant of theta d theta. Keep that in mind. Okay? So just this part, let me just simplify that part. So I'm told the integral of secant to the cubed of theta d theta. I'll just still place my 10 there. I'll get secant theta tangent theta, secant theta tan theta minus the integral of tangent theta multiplied by tangent theta. It's tangent squared theta, so it will be tangent squared theta multiplied by secant theta d theta. From here now, this is where we'll replace tangent squared theta with our Pythagorean identity for that. So the Pythagorean identity says 1 plus tangent squared of theta is the same as secant squared of theta, right? So for us to get our tangent squared of theta, is just taking 1 to the other side, so just minus 1, okay? So we'll replace all those these information with that. So as we said, it's long, but it's worth it. The process can be tiresome. So I'll get 10, okay? The integral of secant to the cubed of theta d theta to be secant theta tangent theta minus the integral of, what's our tan squared? I'll replace it with that, secant squared of theta minus 1, that's our tangent, multiplied by our secant theta d theta. Okay? So that's what we have at hand. As you can see, the math, the integral is long, but it's worth doing. So from there, let's open our bracket. So as opening our bracket, we'll get 10, the integral of secant cubed of theta d theta, okay, equals to secant of theta tangent of theta minus the integral of, open our bracket, will be secant to the cube, remember, secant to the cube of theta minus secant of theta. So the integral is long but beautiful. So we have our d theta here. So from here, as you can see, we'll just split our integral into 2. So I'll get 10, the integral of secant cubed of theta d theta equals to secant of theta tangent of theta minus, I'll split the integral into 2, the integral of secant to the cube of theta minus, okay, I'll just place my d theta, okay, d theta minus the integral of secant of theta d theta. It's quite awesome. So from there, let me place my 10 outside. Keep my 10 in mind. I have my 10. The whole answer I'll get multiplied by my 10. Okay? So from here, as you can see, so this is now the reduction formula. As you can see here, there is the integral of And then that part resembles this part. Okay? So I'll take this part and bring it to my left side. Okay? Because it's just similar. Then the negative part becomes positive on this other side. Then I'll add my coefficients. Okay? We did the same process in power reduction formula. So once you have seen my derivations of power reduction formulas, it will be easy for you. So I'm taking this to this other side. It's just be the same replica, but now we'll have to add our coefficient. So 1 plus 1, when it comes this other side, it will be plus 1, so it will be plus 1 plus 1. We'll get 2, the integral of secant with the cube of theta d theta equals to secant of theta tangent of theta is minus. So we have taken this part the other side, so we'll still remain with minus that, minus the integral of secant theta d theta. Okay? So that's what we have at hand. It's long, but easy, just procedural. So this is what we have at hand. This is the longest question, the integral we have had. So we want our secant to the cube alone. So we'll have to divide by 2. Then here I'll divide by my 2. Again here I'll divide by my 2. Right? So from there the 2 goes with the 2. So I'll get the integral of secant to the cube of theta d theta to be a half of that, to be a half of secant of theta tangent of theta minus a half the integral of secant of theta d theta. Okay? Still the process goes, it's still very long. So from here the integral still continues. So we are told, so the answer is supposed to be this. This is our answer, yes, plus a constant c. But look here. Okay? For me, I'll just write this answer as ln of the absolute value of secant of theta plus tangent of theta, okay, plus a constant c. So this, the integral of this is just this, but I'll try to explain why we have reached here. Okay, so we'll perform these integrals. So I'm told, but check my video on the trigonometric integrals. We saw how to integrate secant of theta. So I'll just integrate secant of theta d theta alone. Okay? When I'm told to integrate secant of theta d theta, you multiply that with secant of theta plus tangent of theta, then you divide it by the same secant of theta plus tangent of theta. Okay? So expand the bracket. So you get the integral of secant multiplied by secant is just secant squared of theta. Secant multiplied by tan, it will be plus secant of theta tan of theta, okay, divided by this part secant of theta plus tangent of theta, but it still got d theta. So choose your u to be the denominator. So my u is secant theta plus tangent theta. Okay, so my du will be, when you differentiate secant of theta, you'll get secant theta tangent of theta, secant theta tangent of theta. Then I'll add this addition. What's my derivative of tan of theta? Is the same as secant squared of theta. Then it's with respect to theta, so it will be d theta. Okay? So from there, okay, I'm trying to explain how we reached here. So from there, as you can see, okay, you can see what is this is secant squared theta d theta plus secant theta tangent theta secant theta tangent. So all these is the same as the upper part. As you can see, it's just the same. So this equals to that. So I will change all the upper part and replace it with the term du. Okay? Replacing that, we'll get, I'll change everything, replace it with u. So the upper term, I'll replace it with u, so I'll get the integral of this upper part, I will get du divided by the denominator. I said choose this denominator to be u, so I'll divide it by u. Okay? Simple. That way. Okay? So it's more long. So this is just the same as the integral of 1 over u du, right? We were told when you're integrating 1 over u, is just the same as ln of the absolute value of u plus a constant c, right? So from there, my answer is ln of u, but remember our u was secant of theta plus tangent of theta, then you add a constant c. So as you can see, that process, what's your answer? As you can see the answer is similar. So for someone who didn't knew, so this is how you approached from here to here through that process. So from there, as we have seen, the integral of secant of theta, it's ln of secant of theta plus tangent of theta plus a constant c. As you can see, now we'll just write the whole answer. So this, let's write the whole answer. So our final answer will be, the integral of secant to the cubed of theta d theta equals to a half secant of theta tangent of theta minus minus. But now what's the integral of that part? So the integral, the answer is this. Okay, so I'll just try to multiply by ln of the absolute value of secant of theta plus tangent of theta. Remember there's a plus here. Okay, there's a plus, absolute value plus a constant c. So this is a post answer, but remember we still had our 10. Okay, we still had our 10. Remember our 10 back in your mind. So I'll just multiply this answer. This is our answer now. Our answer is, so it will be 10. It will be 10 into a half secant of theta tangent of theta minus a half ln of the absolute value of secant of theta plus tangent of theta plus c. Okay? So multiply by 10, you'll get your final answer. So guys, try to smile. We have reached the end. So 10 multiplied by half is just 5. So it will be 5 secant. So this is our final answer, guys, of theta tangent of theta minus 5 ln of the absolute value of secant of theta, okay, plus tangent of theta plus your constant c. So these are final answer. It's very long, but we have reached our final answer. We can continue, but this is where we'll reach for now. This is our final answer for the integral of, for this integral. So when you see integral something like that, it's very long. It's very long. So the integral of this, these are final answer, as you can see. So the process is very lengthy, but it's understandable, having all the concepts of the integration of trigonometric functions, product identities, which I had made videos on those. So far, this is the longest video I've created on solving just one question on this. So this question is from the University of Nairobi. It's the professor. Get my, okay. This is our final answer for this integral. It's an awesome integral, as you can see. Okay. Don't forget to like, share, and subscribe. It's your tutor, the professor. Thank you.